In this tutorial, we are going to talk about galancing collision. So I've got this question which came in one of the exam. So the question is, a buoyant ball B at rest is struck by an identical buoyant ball A moving with a speed of 20 meters per second along the positive x-axis. After the collision, the two balls move off in directions that are perpendicular to each other, with ball A making 30 degrees with positive x-axis. Find the final velocities of both bands, which is the direction and the magnitude. Okay, so when we're talking about galancing collision, one thing should come in our mind is that if we have got two balls moving in this direction, let me put it on top there. So if I've got ball A and ball B, so let's say that this is A and that's B. Okay, so this is before collision. Before collision. Now after collision, these two guys, they are going to move in a separate, in opposite. Another one will go here. So we've been told that after collision, the two balls move off in a direction that are perpendicular. What does it mean? Perpendicular meaning that the angle is 90 degrees. Now in this case, we've been told that A was making an angle of what? 30 degrees. So if I do 90 minus 30, it should be 60, meaning the other one is going to be 60. So I have got my ball here, that's M. Another one will come in this direction. So mind you, these are making 90 degrees. So I'm going to put it like that. So that is going to be my ball B. So I'll put A here, I'll put B here. So we've been told that the angle which is for A, it is 30 degrees. Then the angle, since it is moving they are perpendicular to each other, so it's 90. So now 90 minus 30, meaning the other one is 60 degrees. Okay, so we know that since ball B was at rest but ball A was moving with the velocity which have been told, so the initial velocity of ball A is 20 meters per second. Now what we have to do under galancing collision, so this is going to be now the V1 final, of which we don't know. Okay, V1 final we don't know. Then we have V2 final, we also don't know. It's the one we are trying to find. Okay, so I'm going to have the V final here. I need to put V2 final. So now we can clearly see that after collision, this is now after collision, these two were moving at an angle, meaning that if I get the first one there, it was moving in x-axis as well as in y-axis. So that's my V1 final, meaning that this is V1 fx, this is V1 fy. So since I've got an angle, okay, meaning that if I also get this other one, it's going to be the same. It is coming here, so I've got the x as well as the y. Okay, so I also have V2 final, then this is 2fx, V2 fy. The angle is here. I'll go back to vectors, so katoa. Okay, meaning that the x I'm going to use what? Cos. So I'm going to say in x direction I expect to have two equations since it was moving in x and in y. So I'll say in x direction initially we have got both a and both b. So I'm going to say ma, okay, va initial plus m2, or not m2, let me use mb. mb vb initial should be equal to, even here I should use a, even this one should be b because I've been told what to use. So it's going to be ma va final. Okay, now in this case, since we're talking about x-axis, x direction, so it's going to be x plus ma. Now this is supposed to be mb vb final, now in x direction. Okay, so what I'm going to do, allow me to present this to be theta 1, or theta for a, then theta for b, to make things simple, because those two theta, they are different. So if I just put theta, it's not going to make sense. Okay, so meaning that when we're dealing with vectors in x-axis, it's going to be cos. So I'll go ahead and say, since b is at rest, this is going to be cancelled out. I'll remain with m a va initial should be equal to ma va final cos theta 1, because now we're talking about the first one here. The second one will be plus mb vb final cos theta. Now this theta is for b, even this one I need to specify for a. So this is going to be my equation in x-axis. Okay, now that equation I need to put it here. I need to put it, I'll just shift it, should be on top here. So and then I'm going to go for y direction. So let's go now to y direction. Now in y direction, initially before collision, these two balls were moving in x direction only. So the first initially is going to be 0. But after collision, that's when now it started now moving in y direction here, even here in y direction. Okay, so we'll say ma va final but in y, but since the other one is now coming down, the arrow is going down here, that would that clearly tells us to say it's going to be minus. So here it was positive because they are all moving the same direction, they are moving in this direction. But now the other one is moving in that direction, the other one is coming down, therefore it's going to be minus mb vb final in y-axis. So for y we are using sine, so I'll say 0 should be equal to ma, I'll have m a va final sine theta a minus mb vb final sine theta b. Okay, so this is going to be the formulas which we are going to be using in y-axis for any kind of galancing collision. So under galancing collision, you can't use one formula to come up with the answer. You need to come up with this formula and also that formula. So you need just to know two formulas. Then you start now plugging in the values, the rest will solve themselves. So for example, let me get rid of this because I know that, let me just put it here. Theta for A is 30 degrees, then theta for B theta for B is 60 degrees. Now I can get rid of this. I can get rid of this and rewrite this formula. Or let me first read the question. So the question is saying a brilliant ball B at rest is struck by an identical brilliant ball A. Identical meaning they have got the same masses. So what should come in your mind that the mass is going to cancel out, because we have got the same masses. So the x direction now formula is going to be further simplified as VA initial is equal to VA final cos theta plus, now that is theta A, plus VB final cos theta B. We move this, then I'm going to put y direction here. So what's going to happen is if I want, I can shift this guy to the other side. It's fine. So meaning it's going to be MB, or I can do it from here. I want to cancel M. So this is going to be, I'm shifting this to go to the left side. So we have MB VBF sine theta B is equal to MA VA F sine theta A. Since the mass is the same, we'll end up cancelling the mass. So we'll have the final formula for this question to be VBF sine theta B is equal to VA F, which is final, sine theta A. Now let me create space down here. So we can now plug in the values. According to the data which have been given, the initial velocity is what? Is 20. That is for VA. For this formula, we don't have any initial velocity, and our goal is to find the final velocities. So let's plug in the value from the x direction here. The initial velocity is 20, is equal to VA, we don't know. VA final, we don't know. But we know the theta, that is 30 degrees. Plus VBF, we don't know. But we know the theta to be 60 degrees. Okay. Now, when I do this, I also plug in the values here. VBF sine FB is 60 degrees is equal to VA, we don't know, sine 30. So what I'm going to do, I'm going to make VB as a subject of formula here. That would mean to say I'm going to divide both sides by sine 60. So here I will divide it by sine 60, even here by sine 60. So these will cancel, and I'll end up having VBF is equal to VA sine 30 divided by sine 60. So what we can do to make things simple, we can just say what is sine 30 divided by sine 60? Sine 30 divided by sine 60. So it is, now we are going to have VBF is equal to VA. I should put final. Here I should put final. VA in the brackets now 0.7 or 0.577. Like that. Meaning that in this equation for the x-axis where there is VB, we are going to replace it with VA final times 0.577. So we'll come here and say 20 is equal to VA. We will write it the way it is, VA, but I can find the answer for cos 30. Okay, what is cos 30? So cos 30 is I can write it like this. Cos 30 is 0. You can leave it in 3 decimal places, it's fine. Then VA final plus. So this is going to be where there is VB, we replace it with VA. Okay, we replace it with, it's like we're replacing it with 0.577 VA final, then times cos. Okay, times cos 60. So I'm going to say 20 is equal to, I will write this the way it is, then VA final plus, let's first do what is cos 60. 0.5. 0.5 times 0.577, that is 0.289. I've just rounded off, it's 2885. So I want to be working with 3 decimal places, it's fine. VA final. Now these, they can be added, this guy and that guy. So if I do 0.2, 0.866 plus 0.289, I'm going to find 1 point. So I have got 20 is equal to 1.155 VA final. At this point now, I can divide both sides by 1.155. Even here 1.155. So these will cancel, meaning that my VA final will be equal to 20 divided by 1.155. That is 17.31. 17.32 meters per second. That will be my velocity, the final velocity. Now this is making sense because the initial was 20. Okay, so we don't expect it to be greater than 20, it has to be less than 20. That's what we need to know. So from here now, what else can we see? So from this formula here, we want to find also for the B1, the one we had to make VB as a subject of formula. I'm going to plug in where there is VA with the answer which we have just come up with. I'm talking about this formula here. So it will be VBF is equal to, so VA we have found that is 17.32 times 0.577. So if I do the math here, I can clearly see that, and one thing we should know is that VB is going to be less than 17 because it started moving because of VA. Okay, because of ball A. So we don't expect it to exceed VA. The velocity has to be less than the first one. So we have 17.32 times 0.577. So now the velocity is 10 meters per second. So these are the answers now for the final velocities. Okay. Then let's try to solve another question using the same concept from the previous question which we are from solving. So now we are going to say, here now the question is, a pool ball A of mass MA is equal to 0.400 kg, moving with a speed of VA is equal to 1.8 meters per second along the positive x-axis. Strike another ball B initially at rest of mass MB is equal to 0.500 kg. The collision result in ball A being diffracted off at an angle of 30 degrees with respect to positive x-axis with a speed of 1.8 0.1 meters per second. So if you can remember very well, I said the speed of this buoy initially is going to be greater than the speed of the final. We can even see here. Here it was 1.8, now it's 1.1. Okay, at the same time, we don't expect the speed of ball B, the final which we are going to find, to be greater than 1.1. Yeah. So the first question, write down equation expressing the conservation of momentum in x and y directive separately. It's the same thing which we are doing. So you say x direction, you start from the first. So it will be, in x direction, initially you are going to say we have MA VA initially plus MB VB initially is equal to MA VA final but in x direction plus MB VB final now in x direction. Okay, after reaching at this point, we know that Bob B was initially at rest. We don't expect here this one to be here. So we are going now to have MA VA initially to be equal to MA VA final. Since it is in x, it's going to be cos. So you say this is going to be theta A because we are dealing with A plus MB VB final cos theta B, like that. So this is going to be the equation for the x-axis. Okay, then for the y-axis, y direction is going to be, you start initially when we're talking about galancing collision in y direction, before collision we have 0. It was not moving in y direction, but after collision, that's where we expect now to have MA VA final but in y direction minus, here now it's going to be minus because the other one now, the y-axis is going toward the negative y-axis. So it's going to be now MB VB final in y-axis. So 0 will be equal to MM VA final sine theta A minus MB VB final sine theta B, like that. So this is going to be my equation in y-axis. So for the first question, you are done. Then the next question is saying solve the equation for the speed of ball B after collision and the angle theta B. So we can see that the data which have been given here, we have been given the mass of MA, the velocity of VA, that is initially, the mass for MB, angle for theta A, then again the final velocity for VA. So we want to find the theta, which is for VB, and also the velocity for VB. Okay, so let's go ahead and see what's going to happen. So we start with the first one here. Let's plug in the values. MA is 0.4. The velocity initially, it is 1.8 is equal to MA 0.4. The VA final we have been given. Okay, we have been given the VA final, which is 1.1. So I'll say 1.1. Then I have got cos. The theta have been given, theta for A is 30, plus MB is what? MB is 0.5. The VB we don't know. Fine. Even the cos, the theta we don't know. I'll leave it there. So I can simplify that and say 0.5 times 1.5 is going to be 0.9. Should be equal to, now there I'm going to have, I can start first with cos 30 The answer I find times 0.4 times 1.1. So here I'm getting 0.381 plus. Then here now I have 0.5. I have 0.5. Then VBF cos theta B, like that. I'll leave it here. I'll call that as equation 1. Now I can go back to y direction. I also plug in the values. We see what we're going to have. Okay. So let's plug in the values. So 0, MA is 0.4. VA we have been told that is 0. The final one now 0 or 1.1. 1.1 sine the theta is 30 minus here M, this is 0.5. VB we don't know. The theta we don't know. Let's shift this to go to the other side. So that will be now, let me just say 0.5 VB final sine theta B is equal to, so you have 0.5 or 0.4 or let me just say sine 30 times sine 30 times 0.4 times 1.1, so 0.22. See here. Okay, so this is my equation 2. Now let's see. I think the first thing we can do is here I can shift this to go to the other side. So I can say 0.9 minus 0.381 will be equal to 0.5 VB. This is not supposed to be, oh, this is final. VB final cos theta B. At this point, I can clearly see that it's going to be 0.9 minus 0.381, that is 0.59 is equal to 0.5 VB final cos theta B. At this point, I can now divide. I'm going to divide the second equation by the first equation. The reason why I'm going to do this is because this is having sine and this is having cos. So if I divide the sine divided by cos, it's going to give me tan, which is going to be easy for me. You can even divide cos by sine, but it's going to give you cot, of which you're going to have some challenges maybe to work out. So what I'm going to do now here is, let me create space here. And let me just push this to go on there. And we know that that is our equation 1. Then I'm going to again get rid of this. And I'll shift this to also go there. So we need to divide. The one for sine has to be on top. So we'll say 0.5, I'll start 0.2, I'll start writing this is equal to 0.5 VB final sine theta B. So I divide this by the first equation, which has got cos. So it's 0.519 is equal to 0.5 VB fine, then you have got cos theta B. So we can clearly see that 0.5 and 0.5 can cancel. VB and that one can also cancel. So I'll remain with sine theta divided by cos theta. Then here I have 0.22. If you want, you can find the answer. It's fine. Is equal to now tan theta B, like this. So to find the theta B is going to be tan inverse of 0.22 divided by 0.519, like that. So theta B will be equal to, if I do shift tan, open brackets, 0.22 divided by 0.519. I close the brackets. So I'm getting my angle to be 22.9, which is the same as 23 degrees. After finding the angle, we need to find the velocity for the VB. Fine. Okay. So I'm going to choose any equation for either the first one or the second one, because now I know the theta. So let me go with the first one. 0.519 is equal to 0.5. The V1 we don't know, or the VB, sorry, fine, we don't know, but now it's going to be cos 23 because the angle I know it. So that would mean to say we have 0.519 is equal to 0.5 times cos theta. Or let me just do it. So it's 0.5 cos 23, which is 0.4. 0.46 0.46025. So I'll just say 0.46 VB final. Then the next thing, what I'm going to do, I'm going to divide both sides by 0.46. These will cancel out, and I'm going to have VB final is equal to 0.519 divided by 0.46. So it's giving me 1.128. So it has to be in 3 decimal places, which is VB final will be 1.13 meters per second. I was expecting this to be less than this. I don't know where I've went wrong, but I feel like this is the correct answer. So try to follow the same principle. See if you are going to be able to find 1.13. But in most cases, you are going to find that the VB is going to be less than VA in most cases. But in this case, no. Okay.